In this video, let's work on Raspberry Pi and we'll capture images using a web camera, and then we'll apply filters on them to increase the image quality. That's the objective. So what we'll do is we have the Raspberry Pi and a webcam connected to it, and that has been registered on Raspberry Pi Connect, like the so that we can remotely access it. So now we are just logging in so that we can remotely access it. So we go into the sign in, and then we go to view the user ID password. Yeah, now you can see we have one of the Raspberry Pis which is there in the lab, that is ready. Webcam has been connected to it. So that's, and you can see that is online. So and then the screen sharing also is ready. So we'll just go and connect, and then we'll say connect screen. So it's waiting for the Raspberry Pi to respond. So this Raspberry Pi is in the lab, and that's connected to the internet. And now you can see we have connected to the Raspberry Pi. We can see the screen of the Raspberry Pi over here. And it is also connected to the webcam. So you can see I've done a webcam test in the browser. Then you can see through the webcam this is the text that I'm displaying. So let's see if we can capture this image and try to improve the clarity of this. That's the experiment. So as of now we have just seen the webcam using the webcam test. Let me close the browser. We don't need the browser now. So we'll go and then open the programming, and we'll use Tony as our editor. So we're working, remember we are working on the remote Raspberry Pi now. So and this is the code that is there in our manual. In fact, let me try if we can bring the manual along with this to keep it aside. So let me bring the manual here. Yeah, here's the manual, and yeah, and then this code that is there. In fact, one thing what we need to do is, since this code will be using OpenCV, basically third-party Python libraries, it's very important that once we are into Raspberry Pi, these steps are executed. I have done them already, so this takes lots of time. I mean, on the Raspberry Pi, the system got to be updated, and after that, the Python 3 OpenCV libraries got to be installed. Likewise, these libraries got to be installed, and that has been installed. How do you do that? You just open the terminal. So once you have the terminal over here, so you will have to type those commands, sudo for example, apt get, and those commands you need to type and hit enter. So that is how you enter it, and the system will be updated. Okay, that has already been done. So next thing is what we have done is we have this code that I have copied and pasted. In fact, I have typed it over here. It is there on the Raspberry Pi. So you can see this statement is about using the Raspberry Pi and checking Raspberry Pi and OpenCV, so that the video capture can happen. And then these are few checks, and then after that we have in fact you can see from the video camera, a read has been done and the frame has been captured, and then that frame you can see has been saved now into this file capture image.jpg. And then this is our original image, and then what we are doing, that original image, you can see we are passing it through the Gaussian blur filter, and blurred image is being captured over here. And next thing is what we are doing is we have defined a kernel, a array basically, and then you can see that word image we are passing through the kernel, filtering it, and that is we are sharpening that image. That is called as sharpening of the image. And then the sharpened image is converted into gray, and then that has been captured over here, and then it is being passed, gray image has been passed through the equalizer, and it is captured over here. And then all those images, blurred image, sharpened image, and the equalized image, they have been written, they have been saved, so that we'll open them and see them one by one. So you can see blurred image, sharpened image.jpg, equalized image.jpg. Hopefully the equalized image should be better than the original image. That's our intention. And we are finally showing the original image, blurred image, sharpened image, and the equalized image. So we have this in place. Webcam also is connected. So we'll just run this. So you can see When we run it, it is running over here. It will take some time. It will give some errors, throw up some errors as well. Now you can see all those images have been opened. So it has been captured and it has been opened. You can see, in fact, this is a sharpened image, and like this is, you can see the original image over here. This is how the webcam captured it, and then we blurred it. This is what the blurred image is. Yeah, I'll keep them aside. Yeah, original image, this is the blurred image, and then sharpened image is this, and then the equalized image is this. So it's, you can see we made it into grayscale, and then it's slightly better than the original image. So original image was like this in the dark, and you can see, though we are not able to read the text here, but then we can see after passing through the filter, our image has become a little bit better. That is our objective. And where are these being saved? Where are all these images saved on the hard disk? They are also saved on the hard disk HDD card. So they are saved in IoT Lab, and you can see this is the program. Experiment number 9 is our program, and all those images are saved over here. In fact, equalized image is the final image. Let's open this, and this is what it is. Yeah, this is our objective. We have met our objective. Thank you.